So in this video, I want to talk about density as a conversion factor. Now, we all know that the equation for the density is this, right? Mass divided by volume. Of course, within a mathematical equation, you can plug and chug. You can solve for one to calculate a specific mass or volume. Like, for example, I want to know the mass here in this problem, and so I'd solve for mass. If I go through that process, and I won't do the full thing here because I'm really focused on this idea of density as a conversion factor, it would be this mathematical operation. I would want to multiply density by volume. Let's go ahead and do that, and in the process we'll see how density can be viewed as a conversion factor. Okay, so let me plug my density in here. Right? I have the density of milk given to me in this problem to 3 sig figs, and I am going to write it out in a particular way here. Right, that grams per milliliter, that means that if I weighed out, or if I measured out 1 milliliter of milk and I weighed it on a scale, it would weigh 1.0 grams. Right, so that's one way to express that idea. And what we're looking at now is density not just as part of a mathematical expression, but actually density as a set of units, as a conversion factor. And now let me multiply by the volume that's given in this problem, 15.01 milliliter. And what I see here is I see an expression that, again, it is following the mathematical equation for the calculation for mass, but it's presented to us in a way that looks very much like a dimensional analysis problem. Okay, so remember, in a dimensional analysis problem, if we saw an expression on top, we would multiply by that number. If something is on the bottom, we would divide by that number. And so in this expression, if we were to analyze the units in the context of dimensional analysis, milliliters divided by milliliters means the milliliters cancel out, and we're left with the unit of grams, which is what we want in this particular problem. By thinking about density as a conversion factor and expressing it in a sort of a dimensional analysis pattern, what we can see is actually the particular units being canceled out to confirm that we do have the correct mathematical expression like we see here. And if I did 15.0 times 1.03, I would come up with the answer that's given, 14.6. Now, this is being rounded to 3 significant figures because I have 3 significant figures in my number here, in my data there, and I have 3 significant figures in my data there. Remember, that 0 is going to be significant. The rule is, if a decimal is shown and you have zeros on this far right hand side, then they are significant. They are expressing something about the accuracy of that measurement. Then the rule for multiplication here, we would use the fewest number of sig figs, in this case 3, and that's why we're rounding it to, well, now 3 sig figs. Okay, thanks.